everyone, this is the course on Principles of Behavioral Economics. We are discussing strategic interactions. So, under that we first discussed analytical game, followed by a discussion on the problems of analytical games in terms of how valid they are empirically, and now we are going to talk about behavioral games. But I must tell you that there is no separate category probably of games which can be called behavioral games. Rather, behavioral games are sort of incorporating behavioral understanding or perspectives in the analytical games, and as we have already discussed that experimentations show us that the conclusions of the analytical game theoretic approach may not be always valid. So, there comes the relevance of behavioral games. So, we devote the last 4 modules of strategic interactions to the discussion of behavioral games. Here I begin with an introduction of behavioral games. So, as we know that game theory is a way of understanding how people interact based on the constraints that limit their actions, their motives and their beliefs about what others will do. Experiments and other evidence show that self-interest, a concern for others and a preference for fairness are all important motives that explain how people interact. So, here basically comes the importance of behavioral components, that is when we are driven by concern for others, preference for fairness and all. So, not exactly always driven by self-interest. The outcomes may be different when people are driven by different motives. Behavioral game theory examines the degree to which analytical game theory succeeds in capturing the behavior of real people engaged in strategic interaction and proposes extensions of analytical game theory in the interests of capturing that behavior. So, as you can understand that this is just an extension of the analytical game theoretic approach. Some of the proposed extensions to analytical game theory do not in fact constitute deviations from neoclassical orthodoxy. Thus, there is nothing distinctively behavioral about some of the models discussed under behavioral game theory. Other models, however, constitute real deviations from neoclassical orthodoxy and as such deserve to be called behavioral. Strategic interactions have important implications at levels from micro to global macro, that is at various levels. For example, the problem of climate change is far from unique. It is an example of what is called a social dilemma. So, we are now bringing in behavioral dimensions. Social dilemmas occur when people do not take adequate account of the effects of their decisions on others, whether these are positive or negative. Many nations in the developed world are pressing for strict global controls on carbon emissions, while others whose economic catch-up has until recently been dependent on coal burning technologies have resisted these measures. Traffic jams happen when our choice of a way to get around, for example, driving alone to work rather than carpooling, does not take account of the contributions to congestion that we make. So, we are calling them social dilemma because as you understand that there is a dilemma which one to go for, because both have certain contributions maybe to personal well-being or to a greater social well-being. For example, as we talk about in this context that if I decide to drive alone to work, then that gives me a lot of freedom and a comfort of having my own vehicle, driving my own vehicle to the work. So, I have a lot of discretion, I have comfort also, but a carpool may not give me that much of discretion, freedom and comfort, but that has also certain positive aspect in the sense a carpool reduces the carbon emission. So, many people are getting into one car instead of driving their cars individually to their workplace. So, there lies the dilemma whether I should think about society at large or think about only my own benefit. So, that is why this is called social dilemma. Similarly, overusing antibiotics for minor illnesses may help the sick person who takes them recover more quickly, but creates antibiotic resistant bacteria that have a much more harmful effect on many others. Social dilemma is defined as a situation in which actions taken independently by individuals in pursuit of their own private objectives result in an outcome which is inferior to some other feasible outcome that could have occurred if people had acted together rather than as individuals. So, basically when people act together, like they have concern about others, they are concerned about the society at large, then these are basically, this result in some outcome which is superior to the outcomes when people only think about themselves. In this context, an idea was basically popularized in 1969 by Garrett Hardin called the tragedy of commons. So, Garrett Hardin was a biologist, published an article about social dilemmas in the journal Science called the tragedy of the commons. He argued that resources that are not owned by anyone, sometimes called common property or common pool resources, such as the earth's atmosphere or fish stocks, are easily overexploited unless we control access in some way. Fishermen as a group would be better off not catching as much tuna, and consumers as a whole would be better off not eating too much of it. Humanity would be better off by emitting less pollutants, but if you as an individual decide to cut your consumption, your carbon footprint or the number of tuna you catch will hardly affect the global levels. So, at individual levels maybe it does not have much impact, but collectively it tends to have a lot of impact. So, that is why it is called the tragedy of the commons. Examples of Hardin's tragedies and other social dilemmas are all around us. If you live with roommates or in a family, you know just how difficult it is to keep a clean kitchen or bathroom. When one person cleans, everyone benefits, but it is hard work. Whoever cleans up bears the cost. The others are sometimes called free riders. So, in the context of the tragedy of the commons, there is another concept which is called free riders, basically those who ride on others free of cost, or as the example tells you that someone is cleaning or doing the cleaning business, others are enjoying it. If as a student you have ever done a group assignment, you understand the cost of effort, that is to study the problem, gather evidence or write up the results is individual, yet the benefits, a better grade, higher class standing or simply the admiration of classmates go to the whole group. So, in a group not everybody would be putting up equal amount of efforts, but then everybody gets the equal grades or marks or appreciation. So, again this is the example of some people free riding on others. So, there is nothing new about social dilemmas, we have been facing them since prehistory. More than 2500 years ago, the Greek storyteller Aesop wrote about a social dilemma in his fable Belling the Cat. We all are familiar with this story that a group of mice needed one of its members to place a bell around a cat's neck. Once the bell is on, the cat cannot catch and eat the other mice, but the outcome may not be so good for the mouse that takes the job. So, who is going to bell the cat? Because the person or the mouse that is going to bell the cat is going to die for sure, and it is quite possible that he or she will not be even successful, the mouse will not be successful. So, there could be a few lives that would be lost, but then that is going to result in the savings of other lives. There are countless examples during wars or natural catastrophes in which individuals sacrifice their lives for others who are not family members and maybe even total strangers. So, now we are talking about another behavioral concept which is known as altruism. So, who is going to bell the cat? The mouse that agrees to bell the cat is the one who is ready to sacrifice his life. We call them altruist individuals. These actions are altruistic. Altruism is defined as the willingness to bear a cost in order to benefit somebody else or maybe a group of people, the larger society. Altruistic self-sacrifice is not the most important way that societies resolve social dilemmas and reduce free riding. Sometimes the problems can be resolved by government policies as well. So, altruism is one possible way through which social dilemmas can be resolved. Some people need to sacrifice more than others, but then we can also go for government policies, imposition of certain rules and regulations, restrictions that can help. resolving the social dilemmas. For example, government have successfully imposed quotas to prevent the overexploitation of stocks of cod in the North Atlantic. In the UK, the amount of waste that is dumped in landfills rather than being recycled has been dramatically reduced by a landfill tax. Local communities also create institutions to regulate behavior. Irrigation communities need people to work to maintain the canals that benefit the whole community. Individuals also need to use scarce water sparingly so that other crops will flourish, although this will lead to smaller crops for themselves. In Valencia, Spain, communities of farmers have used a set of customary rules for centuries to regulate communal tasks and to avoid using too much water. So, as you can see, there are a large number of examples where there are either community developed rules that are imposed on the community and the members follow them, understanding that they are beneficial for the larger society, or the government may come up with certain taxes, regulations that need to be followed, again resulting in the betterment of the larger community. Even present day global environmental problems have sometimes been tackled effectively. The Montreal Protocol has been remarkably successful. It was created to phase out and eventually ban the chlorofluorocarbons, or in short CFCs, that threaten to destroy the ozone layer that protects us against harmful ultraviolet radiations. Game theory tools are used to model social interactions in which the decisions of individuals affect other people as well as themselves. When people care about not only themselves but also about others, then we say that those individuals have social preferences. Social preferences are preferences that place a value on what happens to other people and on acting morally, even if it results in lower payoffs for the individuals. Suppose there are n players in a game and the game has an extensive form representation. At any end node, player I can take any value. So, there are n players, so I equals to 1 to n has direct utility of ui. So, basically we are talking about various behavioral dimensions. We talked about how social dilemmas can be resolved through altruistic behavior or through imposition of rules and regulations. When people tend to follow those rules and regulations, we may call that they have some social preferences, that is, preferences for the society might be put ahead of individual preferences. I may not like to go to my work in a carpool, but then social preferences ask me to go for a carpool. So, now I am setting aside my individual preference and following the rule of social preferences, or I am more driven by social preferences. So, that is the idea of social preference. Now, we are trying to model social preferences, and in that context let us consider a game where there are n individuals or n players playing the game, and from each and every action an individual gets a direct utility of ui. Each player has a type that is characterized by some altruism coefficient. Now, note that AI refers to altruism coefficient of individual I. So, if I am somewhere using the term AJ, then that refers to the altruism coefficient of another individual J. So, A basically refers to altruism coefficient. We say that the individual is spiteful if AI is less than 0. You can see that AI belongs to the range -1 to 1 open ended, and which means AI can take negative values also. So, if AI is taking negative value, then we say that the individual is spiteful. I am going to talk about spiteful behavior a little later. Now, for the timing, we will define self-regarding is AI equals to 0. So, basically I am not bothered about others, I am neither spiteful nor altruistic. So, AI is equals to 0, and I will be altruistic if AI is greater than 0, which means I am getting some benefit when others' utility also increases or others are better off. A higher value of AI greater than 0 denotes a more altruistic player. The altruism adjusted or composite utility of player I is given as, so we are calling it VI, the composite utility. or altruism adjusted utility. So, here first of all UI is the direct utility I am getting from any action. For example, when I am going to the workplace using carpool. So, whatever utility I am getting from there, that could be lower than my individual car driven to the workplace, but nevertheless some utility is there. I do not need to walk to the workplace, right. So, the car could be good enough, quite comfortable, though may not be as comfortable as my individual vehicle. Now, whatever utility I am getting, that is denoted by UI, and then this is one component where lambda takes a value between 0 and 1, both included. So, this component is basically the altruism adjusted component. Now, what are the values it take, what does it imply? I have reproduced that expression here. The specification was given by Levin in 1998. In the special case of delta or lambda equals to 0, when lambda takes a value equals to 0, you can see in the denominator I have just 1 and in the numerator I have AI. So, Vi becomes Ui plus Ai into Uj, right. So, depending on the sign of Ai, we have a model of pure altruism or pure spite. When Ai equals to 0 and lambda equals to 0 for all I, then we get the self-regarding case where the composite utility and individual utility from a particular act are basically the same. So, again this is a self-regarding case, I am not bothered about other individuals altogether. Preferences are altruistic if one's utility is increasing in the consumption or well-being of others, and it is spiteful if one's utility is decreasing in the consumption or well-being of others. So, basically when AI takes a negative value, then of course what value this will take also depends on the value of Aj and lambda. So, here one needs to note that Aj belongs to the altruistic preferences of other individuals. Now, I could be altruistic, but the other individuals could be spiteful. If other individuals are also altruistic, then of course these keep on increasing. But if some other individuals are spiteful, some are altruistic, then some of the A's would be negative, some are positive, they may cancel out depending on how large or small are the values. Altruism is unconditional kindness, while spite is unconditional unkindness, irrespective of the behavior of other players. Spiteful behavior can be viewed as the flip side of altruistic behavior. This is the behavior that imposes a cost on others while also involving a cost to the originator of the behavior with no corresponding material benefit. For example, punishing those who throw litter out of their car by yelling at them could be a spiteful behavior. Now, spiteful behavior is not necessarily bad for the society. You have a concern for the society, and that is why you are yelling at individuals, those who are throwing litter out of their car. So, in the above example, it may help to enforce valued social norms. Both altruistic behavior and spiteful behavior confer benefits to the originator that are non-material or psychological. So, basically if altruistic behavior, then for example charity is altruism. So, when you do charity, of course there is a cost to you, some monetary cost, but then you are getting some benefit out of it, and that benefit must be outweighing your cost, that is why you are doing the charity. So, there are certain positive, psychological, non-material benefits. Similarly, in case of spiteful behavior, in this example where somebody is shouting at some other individuals who are throwing litter out of their car, is also imposing a cost on herself or himself by yelling at them. So, anger, frustrations and the effort to yell at others are all cost to the individual who is yelling. But you are doing this because you are getting some benefit, some satisfaction out of it, satisfaction of punishing those individuals, right. So, here this is an example which is basically, despite being spiteful behavior, it is beneficial for the society. It is quite possible that spiteful behaviors are sometimes not beneficial for the society, but in both cases when somebody is doing it, then it implies that he or she is getting some non-material or psychological satisfaction or benefit out of that act. Examples of altruistic behavior include tipping waiters, giving to charity, voluntary unpaid work, monopolists not raising prices when there are shortages, contributing to the provision of public goods, punishing free riders even when there is a cost in doing so. Now we talk about behavioral games. We begin with Ultimatum Game, the most popular behavioral game. In 1982, Guth, Schmittberger and Schwartz reported the kind of empirical finding that surprised only economists. They studied an ultimatum game in which one player, the proposer, makes a take it or leave it offer dividing some amount of money, say 10 rupees or $10, between herself and another person. So, the format of the game is that there is one proposer who makes a proposal of dividing or splitting certain amount of money. If the second person, we call them the responder, accepts the division, then both people earn the specified amounts. If the responder rejects it, then both of them get nothing. In analytical game theory, the proposer will propose the smallest amount possible, say 0.1 or 0.25, and the responder will accept it because it is any positive amount, and anything positive is actually better than nothing. By rejecting, the responder is not going to get anything. So, the proposer, but then responder should accept any amount because any amount is better than getting nothing. This is what the economists understand, and this is what the outcome of the analytical game theory. So, all driven by self-interest, and it will be the subgame perfect Nash equilibrium. By going first, the proposer has all the bargaining power and in theory can exploit it because a self-interested responder will take whatever she can get. If proposers maximize and expect responders to maximize, they should offer the smallest amount. So, this is the format of the ultimatum game. Here is the first player, the proposer. He can make offers like 0, 1, 2, 3, 4, and we can make actually 1,000 smaller divisions of it. So, 0.1, 0.2 and so on. These are the broad divisions up to a maximum of 10 that can be offered. Then in the next move, there comes the player 2, that is the responder. The responder may accept or 0. So, if say a proposal is made of 4 and 6. So, player 1 gets 6, player 2 gets 4. If the responder accepts it, this is the split. If the responder rejects it, then both of them get 0. To many people, the lopsided distribution of the 10 rupees predicted by analytical game theory with self-interest seems unfair. Because the allocation is considered unfair, the way people actually bargain shows whether people are willing to take costly actions that express their concerns for fairness. In dozens of experiments conducted in several different countries, proposers offer $4 or $5 out of $10 on average, and offers do not vary much. Offers of $2 or less are rejected about half the time. The responders think much less than half is unfair and are willing to reject such small offers to punish the proposer who behaved so unfairly. So, here you see that the idea is to give or punish the proposer. Data from a study by Hoffman, Maccabee and Smith in 1996 showed that most offers are close to half and low offers are often rejected. The same pattern of results occurs when stakes were multiplied by 10 and Arizona students bargained over $100. So, here is one results of one study where two different stakes are shown. So, the left columns are of $10 pie and the right columns are of $100 pie. The black portions are basically the amount of rejection, the white portions are amount of acceptance. These are different proportion of pie offered of both $10 and $100, and as we can see that as the amount of pie offered increases, the acceptance rate actually increases. Here the acceptance rate is much smaller. The same basic result has been replicated with a $400 stake in Florida and in countries with low disposable income including Indonesia and Slovenia, where modest stakes by American standards represent several weeks' wages. In experiments, proposers offer an average of 40% of the money, many offer half, and responders reject small offers of 20% or so half the time. The data falsify the assumption that players maximize their own payoffs as clearly as experimental data can. Since the equilibria are so simple to compute, the responders' move is just a choice of a payoff allocation. The ultimatum game is a crisp way to measure social preferences rather than a deep test of strategic thinking. There are many interpretations of what causes responders to reject substantial sums. There is little doubt that some players define a fair split of $10 as close to half and have a preference for being treated fairly. Such rejections are evidence of negative reciprocity. Another behavioral dimension, responders reciprocate unfair behavior by harming the person who treated them unfairly at a substantial cost to themselves, provided the unfair proposer is harmed more than they are. Reciprocity can be defined as a preference to be kind or to help others who are kind and helpful, and to withhold help and kindness from people who are not helpful or kind. And fairness can be defined as a way to evaluate an allocation based on one's conception of justice. This explanation for ultimatum rejections begs the question of where fairness preferences came from. A popular line of argument is that human experience in our ancestral past created evolutionary adaptations in brain mechanisms or in the interaction of cognitive and emotional systems, which cause people to get angry when they are pushed around, because getting angry had survival value when people interacted with the same people in a small group. A different line of argument is that cultures create different standards of fairness, perhaps owing to the closeness of kin relations or the degree of anonymous market exchange with strangers compared with sharing among relatives, and these cultural standards are transmitted socially through oral traditions and socialization of children. Remarkable evidence for the cultural standards view comes from a study by 11 anthropologists who conducted ultimatum games in primitive cultures in Africa, the Amazon, Papua New Guinea, Indonesia and Mongolia. In some of these cultures, people did not think that sharing fairly was necessary. Proposers in these cultures offered very little, the equivalent of $1.5 out of $10, and responders accepted virtually every offer. Ironically, these simple societies are the only known populations who behave exactly as game theory predicts. Whatever is being offered, that is being accepted. Ultimatum game experiments with two players suggest how people may choose to share the rent arising from an economic interactions. So, now we are bringing in the concept of competition in the ultimatum games. But the outcome of a negotiation may be different if it is affected by competition. Imagine a new version of the ultimatum game in which a proposer offers a two-way split of $100 to two responders instead of just one. If either of the responders accepts but not the other, that responder and the proposer get the split and the other responder gets nothing. If no one accepts, no one gets anything, including the proposer. If both responders accept, one is chosen at random to receive the split. The figure below shows some laboratory evidence of a large group of subjects playing multiple rounds of this kind of ultimatum games. So, we have here also, these are the one responder case and these are the two responder cases, the blue bars. Now, you can see that in case of two responders, the fraction of the pie or fraction of offers rejected is always lower. In case 0 or fraction of the pie offered by the proposer to the responder, when it is 0%, then in case of one responder there is 100% rejection. But in case of two responders, only 75% rejection, 25% accepts even 0 offer. In a similar fashion, all the blue bars up to 35% offer are lower than the red bars. When it is 40%, then blue and red bars are of equal size, in the sense the percent of or the fraction of offers rejected is the same. In case it is 45%, blue bars are actually higher. So, competition leads to acceptance of lower offers more, rejections are less, and proposers also tend to offer lower amounts more frequently as compared to the case of one proposer, one responder. When there is competition, responders are less likely to reject low offers. Their behavior is more similar to what we would expect of self-interested individuals concerned mostly about their own monetary payoffs. Unlike the situation in which there is a sole responder, the responder in a competitive situation cannot be sure the proposer will be punished because the other responder may accept the lower offer, and as a result of which overall rejection rates decreases. Consequently, even fair-minded people will accept low offers to avoid having the worst of both worlds. Of course, the proposers also know this, so they will make lower offers which responders still accept. So, with this I conclude this module on the introduction of behavioral game. We will also talk about ultimatum game. In the next, we will continue with further discussions on different variants of ultimatum game. We call them dictator games, and broadly the basic results related to both types of games. These are the references used. Thank you.